Hi, today we'll model a single solar cell, explain VOC and ISC, cover series connections, look at bad cell impacts and hotspots, and show how bypass diodes can help. So we're going to start modeling our solar cell, and we're going to start off with a pump that pumps when light shines on it. We're going to add a pressure tank on the output, so when the pump pumps, the pressure builds here, but we can't let it build infinitely, so we're going to add something else. So here we're adding a one-way valve that can only flow down in this direction, and the thing about this valve is it opens only at pressures above, say, 5 units of pressure. So at 5 units of pressure, it's going to allow flow. It's going to come back up through the pump to the pressure tank and around again. But the thing about it is if this is opening at 5 units of pressure all the time, then the maximum pressure you can have here is 5 units. Here I just connected it to a turbine just to show it doing some work. Here I'm going to show open circuit voltage. It's open circuit because this output is connected to nothing. It's just open. So the pump is pumping, developing pressure in the tank. It's being regulated by this one-way valve, which is actually the symbol for a diode, by this one-way valve that opens at 5 units of pressure. So in this condition, the whole maximum 5 units of pressure is being developed in this tank, which is the open circuit voltage. Here I'm going to show short circuit current. So here we've got the output connected directly to the input. So what you end up with is a continuous and free path all the way around. So the pump pumps, it pumps straight around. No pressure really is getting developed here because it's got a free and easy path all the way around. So what it does is it develops the maximum current possible across the cell. Here I've got 2 cells in series, and this pump is creating 5 units of pressure here. This pump builds on that, and so you end up with 10 units of pressure here. Now the pressure equates to voltage, so in series you're getting your voltages adding together. So 5 here and 10 here. Around this path or circuit, the flow or current is the same at every point. So the current stays the same, but the voltages add up. Here I've got the green showing a good cell and the red showing a bad cell. And what happens here is the good cell is working, developing pressure here, but the bad cell is acting like a blockage. And what can cause that kind of thing is, say if a leaf falls on a cell on a solar panel, it will stop it from functioning or pumping. And in this case, this good cell can't get through here because it's a one-way valve, and it can't get through the bad pump because it's not pumping, but it's pushing against it, and this can create a hotspot or an area of strained flow in this area, and in real solar panels that can actually cause the cell to physically heat up. Here we've done a modification where we added a bypass valve, a bypass diode, and so it gives an alternate route around the cell if the cell goes bad. Here I'm just showing that in practice, where this pump is pumping fine, developing pressure. It gets to here, there's a bad pump there, there's a diode or a one-way valve there, so it takes the path around the bad cell. So now the good cell is able to deliver its power to the turbine. So the bypass diode has solved that problem. Check out my next video on diodes and strings of cells and what reverse and forward diodes, reverse and forward bias diodes mean. And remember, we're just splashing around with water analogies for curious folks here.